By the way, I got 3 more subscribers yesterday. Woo! Okay, we're going to stay. So we're going to do this. Shout out to my new subscribers. Thanks for subscribing. Keep subscribing. And even when you graduate, subscribe with your personal account. All right, here we go. So we have these 10 men. All right, these 10 men. And we have their pulse rate before volunteering to use this new exercise device that's been advertised on TV. You can think of any device you want to talk about. And then this is their pulse rate after using it 3 times a week for 20 minutes. And again, we're talking about 6 weeks from the very beginning. All right, so 6 weeks before and then after they use it for 6 weeks. All right. So the key thing here is, first you ask yourself, is there a relationship between the before values and the after? And the answer is yes, because they come from the same person. Okay, so the moment you see that they are coming from the same person and not 2 independent sampled groups, you know that this would be a problem to do a 2-sample t-test. They're not independent. So that means we're going to do a paired t-test for the differences. All right, the diff. So the first thing I do is I just calculate the differences. So let's go and subtract before minus after. So what's going to be the difference for Alan? 0. What about for Brandon? 4. Carlos? 4. David? 1. Edwin? Franco? Graham? 2. Hans? 1. Ooh, careful! Look at Ivan. Right? Ivan actually went up. His after rate went up. So that's a -1. And then George is 3. All right? So the point I'm trying to make here is after you decide that this is a paired t-test, all you care about are those numbers. I don't even care about any of the other numbers. Okay? Everybody good? Okay, so what's the first thing we have to do when we run a test?
Define the parameter.
Yes, define the parameter. What is up? All right. Let mu sub d. Now, why do I put that d in the subscript?
Difference.
Very good, for the difference. Let mu sub d represent the average difference in resting heart rates before and after using this exercise machine. All right, again, the words are not, it's not imperative that's exactly like this, but something about the difference in the before and after resting heart rates. Okay, who's got questions so far on this parameter mu sub d? Any questions on mu sub d? No? Okay, after the parameter, all right, this one's kind of straightforward here. We're going to make our hypotheses. All right, so what is going to be the null hypothesis? What are we always going to assume about these differences?
Equal.
Now, okay, the equals, we know it's going to be equals, right? That's not changing. What's it always going to be equal to here if we assume there's no difference? 0, right? We're going to assume that the average difference is 0, that this exercise machine is in no way helping their resting heart rate go down. Okay? The alternative, now here's where it gets a little tricky. You know I'm going to have that, but look at the problem. The problem says, is there evidence that this kind of exercise can reduce resting pulse rates? That means, in theory, what should have happened to their after numbers? Should have been down. So the difference we did was before minus after. And if this number is smaller, I'm looking for what? I'm looking for
Difference.
positive numbers. Right? Everyone see that again? I'll do it again. The difference is before minus after. And we're saying, is there evidence that this will reduce their resting heart rate? So these numbers should be smaller than these numbers. So if these numbers are smaller, when I subtract, I get a positive number. So for the alternative, I'm looking for greater than 0, positive numbers. That will tell me if there's evidence. Everybody good with that? Honestly, that might be the trickiest part. All right, deciding what to use for the alternative. All right, now it's time for, yes, the assumptions and conditions. Let's start with the paired data assumption. That's the new one. Let's lead off with that one. All right, who's got it? That's okay. This is the first time we're doing it. I'll do it, okay? There you go. That's a good start. I assume that these, I was going to say groups, but you can say data values. It's fine. That these groups or data values are linked. Yeah, I mean, I'm going to say something else. They're linked. There's a relationship. And what's the relationship? They are from the same person. If you're doing a paired t-test, they will always have a relationship. It could be something like this where it's the same person, Bianca. Sometimes they'll pair people up, right? They'll do like studies with twins, right? Husband and wife, brother, sister. It might just match you up by your age and like your socioeconomic background. Sometimes they might pair you without even knowing the person. Leslie, question.
No, that was basically the same question. Just saying, whenever it's the same person, it's always paired.
It's always, if it's the same person, right, and we're looking at some type of difference, then yes, it will be paired. The key thing for this assumption is to say what the link is. This one I think was straightforward. They're the same person, but it might be a little tougher to see if they're like linking them in a different way. Okay? Sometimes they just match you up by other characteristics. All right? Everybody good? Okay. Now, we don't have to do an assumption or a condition for this one. We're going to go straight to the next assumption, which is the independence assumption. Now, here's the weird part, guys. Because this is all about the differences, your statements are going to be about the differences. All right, so this statement is one man's difference in pulse rate does not affect another man's difference in pulse rate. Something like that. I'll write it down. So one man's difference in pulse rate does not affect another. All right, so I think that's one of those like nuances that it's a little different because mostly we've been talking about groups, right? In this case, we're talking about just the differences. Remember, that's all I care about, the difference. Okay, what is the first condition I'm going to check? Randomization. Now, does it mention anything about these 10 men being random, a random sample? It doesn't. It actually says that they're what? Volunteers, and that worries me, right? I get a little worried about volunteers, all right? Because when I think about who's volunteering for exercise, I'm thinking of people who exercise, all right? When I hear, oh, come volunteer for exercise, no, I'm good, all right? Plenty of that. So in this case, you're going to write that statement.
But they don't know it's exercise.
We don't know, right? Oh, wait, you're saying that they're volunteering for something they don't know? Bold, right? Bold. You should always read the fine print and ask, okay? If you go to college, I think I told you, maybe I didn't tell you guys, I volunteered for like a psychology experiment in college. You good? My school required you to do one if you were taking a psych course to help the grad students in their projects. They made all the undergrad students like do that. Did I never tell you this story? No. Oh my gosh, really? Oh. So I went to the psych building, and I went into a room, and they showed me a picture of a horse that said, draw this horse. And I was like, I'm not very good at drawing. They're like, just do your best. Don't worry about it. I'm like, okay. So they're like watching me. And about 5 minutes into it, the alarms go off. Like the fire alarms, like really super loud. And I was like, should we go? And they didn't say anything. And I realized, it dawned on me, this was not about the horse. It was about what I did when the alarms went off. So I got up and left. Well, that's the fire alarm, right? You're supposed to get out of the building.
So they was just.
Well, I got credit for it, so. No, I definitely did not. I was like, this horse looks terrible. Oh God, I wish I should have gone back. Horse. Man, that drawing was terrible. It was terrible. My goodness. Okay.
Well, they were just staring at you?
Yeah, they're staring at me. They didn't say anything, so I was like, so I just got up and left. I was like, it could be a fire, so I'm leaving. Okay. The random. No, I just said, and I left. Okay. The randomization condition. So because they're not random, this is where we're going to write that statement. Remember the statement? We have to assume that these men are a good representation of all the men. All right, so that's what we want to write. These 10 men are a good representation of all men. Yeah, this always cracks me up because my wife, her resting pulse rate is so low because her body, like for some reason, just like is able to pump blood so well that her resting heart rate is so low that whenever she's hooked up, like especially when like during pregnancy, that the monitor would beep and think she's dead. So like the nurse came in, "Are you okay?" And I was like, "She's fine. It's just her pulse rate. She's totally alive. Don't worry about it." Seriously, the monitor would like it's fine.
She's alive.
She's good. She's okay. She's fine. Oh, so good. Okay. The 10% condition. I'm sorry, Jarvis. Okay. The 10% condition. So this is a sample size of 10. So if you multiply it by 10, you get 100. All right, so we're asking ourselves, are these 10 men coming from a population that's more than 100 men? Right? And if you're not thinking of the song Africa by Toto right now, I'm a little disappointed.
What?
Yes, you have. I'm like, hey, there's like 100%. You heard the song.
I think we need to. Yeah, we need to.
We'll do it at the end. That's what I'm singing right now when I wash my hands. If you sing the chorus twice, that's 20 seconds. Oh, we'll do it at the end. Anyway, do we think there's more than 100 people? All right, let's do the last one. The normal population assumption. I put that there's more than 100 men in the population, right? So we're saying as long as this sample of 10 men comes from a population that's more than 100, then it's not more than 10% of the population. So our sample size would not be too big. All right? Now, this one we've checked before, the normal population assumption. This is saying that if we knew the differences for all the men, right? We're talking about all the men, and we had their histogram, what would that histogram look like? Unimodal. And actually, because we're assuming it's normal, you can take out the roughly part. Just say, we think it's unimodal and symmetric. Perfect. All right? It's a perfect histogram. Unimodal and symmetric. That is normal. Should I write that? Okay. If I knew the differences for all men and had that histogram, it would look normal. Unimodal and symmetric. Now, do we have that? No, we only have 10. All right, so what I do, what I was trying to show you guys last week, is I go to Desmos, I type in the 10 differences. Right now, all I care about is differences, and I want to see what that histogram looks like. All right, let's see what that looks like. I did it earlier. Okay. I did cheat, yes. In teacher world, we call it just being prepared, not cheating. Okay. Okay, what do you guys think?
No.
No. Well, I mean, they have more than that, right? Let's say no.
It's skewed to the left.
Skewed to the left? Okay. Ooh, be careful, right? Well, I don't. It's not that I hate that word. It's just put a word in front of it. Possible. Yes. Remember. All right. I prefer potential, but that's okay. Possible. Possible outlier at 8. Right. Who's this guy? Maybe Franco. Franco. Possible outlier here with Franco. Right. Well, no. The 8 is all I care about. Right. Again, all I care about are these numbers now. Okay? No, interesting negative. Do I think that is a problem with that? Maybe it's causing that. I think it might be skewed. All right? So you just want to sketch it. All right? The key thing is here, you got to sketch it. So right now, sketch this on your paper. Sketch this histogram, because when someone else reads your report, they are going to make their own decision on if they want to keep going or not. No, not in the mechanics. Just to the side, just small. Real super small, right? Something small here. Something like under here. What was it? A big hump there, space, and there was like something like that. Just a quick sketch, right? And that's called the nearly normal condition. Again, you don't have to name these. You're not getting points off if you don't name them. All right? But I do want to see that sketch, right? On the test on April 1st, I got to see that sketch.
And do we put that it's skewed to the left?
You can put that it's skewed. You can say, I'm worried that it's not roughly symmetric and unimodal. All right? But I'm going to keep going because otherwise we'd stop. So I'm going to keep going. You make the call. Okay, now we're ready for what?
Mechanics.
Be careful. The sentence, right? Remember that sentence? All right, the conditions have been satisfied. Or met. Met is fine. Met is totally fine. Right? Conditions have been met. Conditions have been satisfied. So I will use a T model with, who knows what I'm going to say here? With, hold on, be careful before I say that. With, whenever I say T model, degrees of freedom. With how many degrees of freedom? 9. Good. With 9 degrees of freedom to run a paired t-test. Whew. Good work, guys. We're doing great. You're doing some serious work here. Right, that is not serious. That is complete waste of your time. All right. Oh, I'm so sorry. You were still writing. My bad. Well, I don't have to imagine. I've been in many calculus classes. We ready? Mechanics time? Let's do it. All right. So I'm going to use this half. So I'm going to write down the stuff that I know. I know we have a sample size of how many men? 10, right? We have degrees of freedom of 9. Now I'm going to need, D bar, right? The average difference, which I don't have yet. And I'm going to need the standard deviation from that sample. All right? So you can use the yellow calculators now if you'd like. This is where you'd go to one list, right? Hit stats. Not stats. Data. Hit data. But I'm going to use Desmos. Okay? But you can use the yellow calculator. It doesn't matter. And I'm going to type in the mean. Oh, I don't want capital. Get out of there. Mean. Where's my parentheses? Of D. Did it give it to me? Yes. It did. You guys see the average difference? The average difference is 2.8 beats per minute.
Oh, it's the same.
Say it again.
It's the same on yours?
You should. Are you doing it on yours?
Yeah.
Did you get 2.8? Then you're good. Nice work. The standard deviation. Okay, don't tell me, Bianca. Okay, so let's see. ST. No, stop doing the capital. Let's just type it in there. Oh, now you got me all messed up. Go. There you go. Okay. STDV. All right, so I got 2.8 2.53. 2.53?
Yeah.
2 point. Is that what you got, Bianca? Uh-oh. No.
You look at the SX?
Yes, I think it's number 4. SX.
Yeah.
Three.
Uh-oh.
Oh.
It's number 3? It's number 3. I lied. Number 3, right?
You tripping. You big tripping.
Don't unsubscribe.
You almost lost me at this point.
Because this one's too long.
So you have a number that's wrong.
Yeah, I'm not 2.5.
You're almost
That's right.
I don't want to go away. I want to hit that. 0.44. Did you type in the last 3 at the end? See how there's a 3 here? Got it? All right, what'd you say, so? D bar is 2.8. X bar, D bar, Y bar, all the same. Bars, averages. You probably typed in the before or after column, right? All I care about is the difference column. Good, got it, Gamma? Good. Okay, so let's do our formula. It's T with degrees of freedom of 9 equals D bar minus 0 over the standard error of D bar. Let me say it again. We're finding our T value. All right, this is our critical value here. T with 9 degrees of freedom equals our sample average for our differences, which we have, minus 0 because we think that there's no difference, over the standard error of that D bar. So it's going to be 2.8 minus 0 over 2.53 over the square root of 10. Okay, and you know from here I'm going to go where? Math cracker!
My boy.
It is. Me too, man. All right, let's say February 26th.
Yeah.
That's where I was. Yeah, one time. Oh, wow, we're so in March now. Yeah, I need to just make it, okay? You know what? Okay, Catherine, I get it, okay? I get it. I'm always trying to improve. So clearly, I have a ways to go. Okay. Jarvis, where's Jarvis? There we go. Okay. Now, here's the thing. I don't know if you saw that. Almost done, guys. Almost done. I don't know if you saw that. Shh. But I clicked the link for one sample t-test. Everyone see that? I clicked the link for one sample t-test. There's no link for a paired t-test because a paired t-test is just a one sample t-test. I want to make sure you guys understand that. When you take the test on April 1st, don't be looking for a link that says paired t-test. It is a one sample t-test. Okay, so we said for our null obviously is equals. The alternative, greater than. What do we think right now is our best guess for mu sub d? No.
Oh, it's still 2.5.
Nope, it's 0. Remember, this is mu. We think right now that mu sub d is 0 before we actually run the test. We think there's no difference before or after using this machine. All right, what is the average difference from our sample? 2.8. Okay, what is our sample standard deviation? 2.53. Great. Sample size? 10. And then for our significance level? Sounds good. All right, and solve.
I like how there's no ads.
Me too, man.
Needs stats help.
Needs that.
That's not an ad, though. That's like, it just takes you to the website.
Wow.
I don't.
You're trying to replace it.
Okay, here we go. All right, so our t-value here is 3.5. So let's write that down. 3.5. And you should have, if you flip over the next page, you should have a blank slide to draw your curve. And where is 3.5 going to be? Way over here. And which way are we shading? To the right. For greater than is to the right. So that area that we're shading is called our p-value. And our p-value is 0.0034. And my first thought immediately when I see that p-value is that it is below our alpha of 0.05. So we're going to reject the null in favor of the alternative. All right? So what are we saying about this exercise machine? Nothing, apparently.
Sorry, I'm writing.
Oh, my bad, sir. What are we going to say if we reject the null in favor of the alternative?
There is not enough evidence.
No, there is enough evidence, right? Because p-value is low.
To show that the heartbeat,
They're not paired.
That the average difference in your resting heart rates is significantly different before using the machine and after using the machine. All right? I'll do it again. All right? So we're saying that there is enough evidence. Yeah, the conclusion. There is enough evidence to say that there is a significant difference in your resting heart rate. I'll just write it down. There is enough evidence to say there is a significant difference in your resting heart rate before and after using this machine. If you ever have seen an ad for some type of exercise machine or equipment, like Bowflex is always an ad that I see, all right? And they make these, or Peloton, they make these statements. Well, they're making these statements based on, obviously, larger scale versions of this, all right? That's where those statements come from, right? If you were to actually go in and find their data, this is essentially what they're doing, all right, before they make those claims on their advertisements, okay? Okay, who's got questions on how to run this?